Welcome back. We are still in Unit 2 and we are discussing primitive data types. We're looking at if statements and we're going to get down to loops at some point. So we just looked at this and we are here now. We're looking at precedence of operators. An example is when you try to simplify the ambiguity of your statement, like I explained to you the last time. It's nice to tell the compiler that this is what you mean and no, that's not what you mean. So this is ambiguous. Most times the compiler is not sure what to do with it, but if you're lucky, it goes about evaluation based on the precedence of operators. So this is done first before adding X to it. However, if you really want to enforce the precedence and say that this is what I want to do, then you have to write like this. And that allows you, that's the recommended way because it becomes unambiguous. Ambiguity means something that means many things. Like this is ambiguous, so it means many things. This could be x plus y divided by 2. This could be x plus y divided by 2. And those things have different values, or different expression values. So you can really look at that. And here is another example. And I want you to try this on your Visual Studio. If A is 5 and B is 4. Now let's look at those operators we mentioned. Then 5 plus 4 will be evaluated here, which the answer will be 9. All right. So when you console the print line, you expect 9 to appear. However, if you B plus plus, means that add 1 to B, all right? However, it is add 1 to B after this line is executed. That's what this means, B plus plus. There is another expression in C# called plus plus B. That one is different. It means before you even execute this line, just add 1 to B first. So let's look at these evaluations. A is still 5, B plus plus. Because we are adding 1 to B after this line, so B still remains 4. So the output is going to be 9 still. All right. Now, the moment I get to this line, B is now 5. You know that because here we added 1 to B after that line. So we have A plus B now is now 10 because that's 5 plus the current value of B, which is going to be 5 with this one. So we're going to get 10 here. Now, let's look at this. A is 5, we know. B is also 5. However, we have plus plus B, meaning that add 1 to B before you even execute this line. But B was 5 plus 1, that would be 6. So 5 plus 6 will give us 11. Make sense? Then we get to next line, we have A plus B. We know A is 5, B is now 6. That will give us 11 still. Then 14 divided by A. A is 5. So when you divide 14 by 7, you get 2. However, when you divide by 5, the decimal point is truncated because this is an integer and this is another integer. So 14 divided by 5 will give you 2 here because it's supposed to give you 2. Let me get you the actual decimal value. All right, we're almost there. 14 over 5. The actual decimal value is supposed to be 2.8. However, because 14 is an integer, A is an integer. When you divide two integers, you're always going to get a truncated value. So instead of 2.8, you're going to get 2. So that's the value there. However, this is mode operator, 14 mode 8. Mode A. How many 5s can you find in 14? That's the question. And what is the remainder? So we can find 2 5s in 14. That's giving us 10. The remainder is 4. So the answer is 4. So that's just a display of all these operators, a few of these operators. And logical operators, again, this is just an example. Remember truth tables from Python. So X, Y, and not X is here. So not of true will be false. And you can trace this table. Again, it's just the same thing. XOR, in case you forgot, it's only true when the two inputs are not the same. Okay. So it's going to be false here because the true inputs are the same. It's going to be false here because the true inputs are the same. However, for the two middle rows, this is true, this is false. This false is true, so the true inputs are not the same, and it is going to be true. All right, let's move on. More examples. So here you have A is true, B is false. A and B will be false because it's only true if both, and is only true if both inputs are true. So or will be true because that only requires one side to be true, and because we have one side is true here, it's fine. Not B. B is false, so not of that will be true, And B, because it's false or true, will still be true because you have at least one item to be true. Then you have 5 greater than 7, that is true. XOR A equal to B. So is 5 greater than 7? That is not true. All right. Is A equal to B? That is also not true. So since both sides are false, the XOR is only true when both sides are different. So that's going to be a false. All right. So guys, we continue concatenation. Again, you've seen that last week. That's just plus. You can trace what I have going on there. Bitwise operation, they're like relational operations, just that in this case they have they're working on bytes, on bits, and not on. Let me show you an example quickly because you can be wondering what's a bit. So the other operators, they are called Boolean. So Boolean, let me say X is Boolean, and the value is false. So if I say Y is Boolean also, Y should be equal to not X. All right. Again, and I can now display, let's display console the right line. X, let's display Y. All right. So if I F5 this, as you can see, the value is true. Why is that? Because this is false. Y is not of false. Not of false is true. And that works perfectly well. Waiting for my computer, it's thinking too hard. All right. Okay, so now let me show you an example of bitwise operator. So the data type is called byte, okay? And let's call Z a byte, okay? And it could either be 0 or 1. So I'll say this is 0. And then I will apply the Boolean operations on it. So let me use 2 parameters here. Let's say A and B are bytes. All right. And let's say A equals 0. And let's say B equals 1. And let's say another byte called C equals, I can now say something like 0 or 1. All right. And I can now display the value of C. Copy, paste, display C. So I'm expecting C to be, this is O. However, with relational operators, O is 2 strokes or 2 poles. And here with the byte, O is 1 pole. All right. So I can display C, and C, I'm expecting C to be true, which is going to be 1. All right. So I'm going to F5 this. One thing I missed to do before I F5 it, my control read key, I want to put it at the end of my code so that it can show me the execution of everything. Now F5 it all over again. Great, so I'm going to show you the outputs now. On my other screen, dragging it. All right, so you can see the first one is true. That's the outcome from this part of the code. This part is also 1. All right, so this is what bitwise operators is. Instead of using true and false, it's just zeros and ones. So 0 meaning false and 1 meaning true. All right, we proceed. Relational operators or comparison operators, I've explained that to you. It's the same in Python. Just the equal to is double equal to here. Not equal to is this one, but other things follow through. Here's an example. If x is 10 and y is 5, this is how all of these things we evaluate. So if you display this literal and you put this next to it, x greater than y is going to check if that is greater. It's going to give you true. This is going to be false, obviously. Is it greater than or equal to? That's true. Is it less than or equal to? So 10 is not less than or is not equal to 5. That's false. So I want you to trace this. Are they equal? That's false. Is it not equal to? That's true. So please trace that. Test it out. Works perfectly well. Cascaded expression. So in C#, you can assign values to all of the variables this way. So you can say x equals y equals z equals 25. And you can keep going. All right. So that works perfectly if you need to initialize more than one variable at once. So let's say that you have 3 variables, int a, b, c, or d, 4 variables. and you know that all of them are 0 at first. So you could say A equals B, equals B equals C equals C equals D equals 0. All right. That way, at once you can initialize all of the variables, and if you display them, the values will all be 0. All right. So it's called cascaded initialization or assignment, and that's an example of it. And compound assignment, here's another one. Multiply equal to, so this is an equivalent of x equals x times y. All right. So if x is 2 and y is 4, so the new x should be 2 times y, which is 4, which is 8. However, that expression you can write that x times equals y. You can test it also for plus equals, minus equals, times equals, and division equals. Alright, so I would start up this part from the next video. I don't want the videos to be too long, you know the drill. See you on the other side.